Welcome back to the CCNP ENCOR course. In the previous video, we discussed the fundamentals of quality of service and why QoS is required in modern networks. In networks where applications require different levels of service, traffic cannot be treated equally. For example, a voice and video traffic are highly sensitive to delay and jitter, while the applications such as file transfer or email can tolerate some delay. Because of this different application requirement, traffic must be sorted into different classes so that appropriate QoS policies can be applied. This brings us to the topic of this session, classification and marking. Classification and marking are two critical functions of any successful QoS implementation. Let's start by first understanding classification. So what is classification? Classification is the process of identifying network traffic and grouping packets into different classes so that appropriate QoS policies can be applied. And to do this, a network device must first determine what type of traffic a packet belongs to, and then it can classify accordingly. But how does a router or switch actually determine the type of traffic inside a packet? Let's see how the classification works. Classification works by examining specific field within a packet header. These fields are known as traffic descriptors, and they help the network device determine the type of traffic the packet represents. Now, the next question is, what exactly are those traffic descriptors that network devices inspect to classify packets? So, traffic descriptor can exist at different layers of the network stack, allowing classification to occur using multiple packet attributes. Some of the common examples include layer 1. At layer 1, you can have descriptors physical interface, subinterface or port. And at layer 2, MAC address and 802.1 CoS bit or class of service bit. And at layer 2.5, which is between data link and network, MPLS exponential experimental bits. And at layer 3, we have DSCP, IP precedence, and source of destination IP addresses. And at layer 4, we have TCP or UDP port numbers. And at layer 7, we have application identification using NBAR2. A quick overview of what NBAR2 is. It's a next generation network-based application recognition protocol, which is a Cisco IS feature. It's not a protocol, it's a Cisco IS feature that provides intelligent application-based traffic classification. It can recognize a wide variety of applications like Telnet, SSH, and including those that dynamically use TCP or UDP port numbers. Based on those descriptors, the device assigned the packet to a specific traffic class, allowing QoS policies to be applied. So in enterprise network, the most commonly used traffic descriptors are typically found at layer 2, layer 3, layer 4, and layer 7. So now that we understand how packets are classified, the next important question is, where should this classification be performed in a network? In the most network design, packet classification should take place at the network edge, as close to the source of the traffic as possible. So once once the traffic has been identified and classified and where we need to place, the next step is to mark the packet so that other devices in the network can recognize their priority. So this gets us to the next topic, that is, what is marking? Marking is a QoS mechanism that colors packets by modifying specific field in the packet or frame header. These markings allow packets to be distinguished from other traffic, enabling network devices to apply appropriate QoS mechanisms such as policing, queuing, congestion avoidance, or remarking. In simple terms, classification identifies the traffic while marking labels the packet so the rest of the network knows how to treat them. So the next question is, where exactly are these markings placed within a packet? Network devices use several fields within a packet or frame headers to mark traffic. And some of the common traffic descriptors used for marking include, for internal marking, you can use QoS groups used within the router. And at layer 2, you can use 802.1q class of service bits. And at layer 2.5, MPLS bits, EXP bits. And at layer 3, DSCP and IP precedence. So in the most enterprise network, the most commonly used marking fields are layer 2 and layer 3. So let's see what layer 2 marking is. Layer 2 marking in Ethernet network is implemented using IEEE 802.1q VLAN tagging standard. Within the 802.1q tag, there is a field called PCP, Priority Code Point, which is used for class of service marking. The PCP field is 3 bits, allowing 8 priority levels from 0 to 7, where 0 is the lowest priority and 7 is the highest. However, QoS marking exists only in 802.1q tag frames. But if the traffic passes through a non-802.1q link or a layer 3 network, the QoS marking is lost. Because of this limitation, QoS marking is often applied to a layer 3 where the marking can be preserved end-to-end across the network. Let's look at what layer 3 marking is. Layer 3 marking is implemented using fields in the IP header. Layer 2 is in the frame and layer 3 is in the IP header, specifically within the type of TOS byte. Originally, only the first 3 bits of the TOS field known as IP precedence were used for QoS marking, allowing 8 priority levels from 0 to 7. Later, diffserv redefined this field as DS field, where the first 6 bits are used as a DSCP value, allowing 64 possible QoS markings. That's it for this session. So let's look at what we last but not least, this DSCP is the most commonly used layer 3 marking in the network today. Because DSCP, as I said, is the most commonly used layer 3 marking because it provides more granular traffic classification and is preserved across layer 3 networks. So to summarize, I would say in this session we discuss how QoS classification identifies traffic and how marking is used to label packets so that network devices can apply QoS policies consistently across the network. We also looked at layer 2 marking using CoS values and layer 3 marking using DSCP values, which are the most commonly used marking methods in modern network. Whereas DSCP uses 6 bits in the IP header, allowing up to 64 different QoS marking values, which provides much more flexibility when designing QoS policies. So in the next video, I'll discuss about policing and shaping. And I think before that, not policing and shaping, we'll do a small lab, a hands-on lab on classification and marking using MQC. For more such content, please do like, comment, share, and subscribe. Thank you.